Some formulas, like the EOQ, can be deceptively simple in a certain sense. This short problem right here is a good example of that. The demand for an item is 10 per month. The cost of placing an order is $15, and the cost of holding one item in inventory for 1 year is $25. What is the EOQ? Now, what did I mean by deceptively simple? Well, EOQ is just a formula. Whoops. And it's not even a very long formula. It's the square of 2 times D times S divided by H. So to answer that question right there, we just need to work that particular formula. And I see pieces of it in this one sentence right here. S is the cost of placing an order, and that is reported at 15 right there. H is the cost of holding 1 unit in inventory for a year, and that's just reported right here. So we have that. D is annual demand. So it might be that you tried to work this problem, but you didn't get the answer because you saw S was 15 and H was 25, and then you put in the 10 for D, and then it doesn't work out. We have to remember that D is annual demand. Notice the italics in this particular problem, drawing our attention to the demand for the item is 10 a month. D and H basically have to match. That's how the EOQ formula works. You know how H is always the cost of holding 1 unit in inventory for a year? D has to be speaking of the same thing, a year. Anyway, for this problem, it's not hard to correct it. If the demand is 10 a month, then capital D, the parameter that we're looking for, is then just 10 times 12, 12 months in a year, 120. Now we have everything that we need to find the answer, right, which you just say 2 times 120 times, what was that, the 15, that's all in the numerator, divided by the 25, that's in the denominator. So I get this is actually the square root of 144 in here, which that works out nice and neat. No rounding or anything, 12. Yeah, okay, the EOQ in this case is 12. This next problem concerns inventory dynamics. Suppose annual demand for a certain item. Now again, you know, symbolics, I'm going to take some notes. We were just saying the D was annual demand for a certain item has decreased dramatically. Okay, so D has gone down this year, although the store that stocks this item has not updated its inventory policy, so that the store will still be using the same order size. Okay, that right there, that's Q, and the same reorder point established for that item when it was selling better in previous years. Okay, so when D was larger. What will happen to the, okay, here's the actual question. What will happen to the frequency of ordering? I need to remember that the frequency of ordering, that would be the number of orders a year, is D divided by Q. In any situation, right? Take the annual demand, you divide it by the order size, it reveals the number of orders a year, and that is one way to speak of the frequency, how many orders a year that you placed. Oh, all right. Now, this problem, well, wait a minute, I don't have any numbers. Yeah, it's just asking for the inventory dynamics, because basically there's this situation in which they have an old D, right, back when demand was large, and what they're warning us now is that there's a new D, so to speak. Now wait a minute, D is the annual demand in each case. D divided by Q is the frequency of ordering. They're actually asking, okay, what does this expression, how does it compare to that one? Well, they were just saying that the store uses the same order size, so the denominator's the same. The only thing that's different here is old D is larger than new D. They said that demand has decreased. Okay, so that means that this ratio here would be smaller than that one. This would be a smaller number than this one. Yes? Oh, that's what would happen to the frequency of ordering. Frequency of ordering would decrease, right? That new result's going to be smaller. Another way to check our understanding is just picture this. Demand for some item has slowed down dramatically. They're still using the same order size, so they're always getting the same amount in. That means that their orders would last them longer because they're not using up the orders fast enough, which means that you wouldn't order as frequently.